All right, it is day 18 in geometry. We are in unit 3. And you're due now today. Give you 4 problems. You're finding the area and the perimeter of each quadrilateral below. And then the 4th problem was a challenge question where you find the area and perimeter of a triangle, which we have not covered yet. So if you couldn't figure that one out, no big deal, but we will go over it together. So starting with number 1, and really for any of these, does anybody remember the formula I gave you yesterday for area?
Base times height.
Base times height. I'm going to write that at the top of my page. Area equals base, or B, times H, height. Base times height. So we're going to keep that in mind as we do the area for number 1. What type of shape is this?
Parallelogram.
Parallelogram. Good. Our opposite sides are equal. They're parallel to each other. Even though it's not marked, we can kind of assume that from our picture. If I wanted to use the area formula, base times height, which numbers will I use? Which number would be my base?
The 12.5.
Yes, 12.5. That is my base. And then our height. We have 2 options, 8 and 9.2.
I don't think the 8 would be because it's the length.
So you might be thinking 9.2 because it's actually touching the shape. 8 is inside the shape. When we're talking about height of a shape, we're thinking about height from the base at a 90-degree angle.
So the straight line.
The straight line.
The straight line. We're going to use 8 as our height. We would call 9.2 a side length. S.
Side length?
Yes. So we can label that with an S for side.
No.
Yeah, side length. H is our height. B is our base. Make sure writing that alongside. I might write that too.
So we gotta do the 12.5 times 8.
Yes. Area, we'll just use that base times height. Base is 12.5. 8 is height, so we'll multiply those. So let's do that. A equals B is 12.5 times H is 8.
Eight times 12.5 times 8.
Yes.
100.
100. Exactly. Wow. Okay, so our area is going to be 100. What are our units going to be? Squared. And we have inches here. So we're going to write inches squared. 100 inches squared. So if I had 100 little inches or 100 little squares that were all 1 inch in size, they would all fit inside of this shape is what we're saying.
Okay.
Yes.
Inches square.
Yes, inches squared.
Okay, so where did they come from?
Where did inches squared come from? I will show you, because we actually didn't even talk about this yesterday. What we're doing here is 12.5 inches times 8 inches. So whenever we do our 12.5 times 8, that's where we get our 100.
Is it because we have multiple sides?
Kind of. kind of. It's more so because we're not measuring a length, we're measuring an area, a space. So inches would talk about how long something is. Inches squared is how many squares can I fit in there.
Oh, okay.
And the other thing is if I take the 100 here, I got the 12.5 times 8. I'm also doing inches times inches. And when I take a number times itself, for example, think back to algebra, x times x equals x squared. Inch times inch equals inch squared.
Is it just like that for area?
Yeah, just
Okay.
for area. Or if I had 5 times 5, that would be 5 squared.
That's 5, yes.
Yeah.
That's the.
So that's where we get the squared from, and that is only for area. Only area.
But then, oh, okay.
Now we're going to see also.
So that's like saying 100 times 100 equals 100 squared.
Kind of. We're saying if I had, this is, okay, so for example, this is an inch
Okay.
right here. This is an inch squared. I'm saying I have 100 of these squares.
Okay.
I don't have a line that's 100 inches long. I have 100 of these inches that are squared. Because that measures space. Regular inches measures length. Okay. Really good questions, guys. All right, I'm gonna move that.
Oh,
Yeah. Oh, sorry. I
I
didn't
needed
need
that.
that.
Sorry.
That's okay. That's okay. I wasn't sure if anybody was writing it. Just gonna read this if I did not. Just write down. First area I get back. Good. So here, let me pause this while I see quite a few people kind of writing that note down. So I'm gonna give you guys time to do that. Okay. So we found our area, 100 inches squared. And now we're gonna talk about perimeter. And perimeter, what is perimeter?
Not the entire round.
Yeah,
Yes,
it's
the
the
outer.
length around
Yeah.
the shape. So we don't need to use a formula for perimeter if we don't want to. We could add all the sides together.
Okay.
But what is that formula I gave you yesterday?
Perimeter is 2 times length plus width.
Yes, length and width, although we actually use different letters in our notes. You can use length and
Well,
width.
that's what letters were up to. That's what
Yes.
you did.
So we have 2 times, we're going to call it B for base, that would be your length, and then S for side, that's your width. So 2 times B plus S. And the reason for that is because in this shape here, this parallelogram, my base, notice how we have 2 tick marks on this side length, that 12.5.
Mhm.
There's 2 tick marks on this one as well. What does that mean? They're the same. So this is also 12.5 inches. So really we're taking that base times 2, and then we're adding it to the side here has 1 tick mark. Side across from it also has 1 tick mark. So there's 2 of them that are 9.2. That's why we're taking that times 2.
Oh, okay.
So again, you don't have to use the formula. You could just add 9.2 plus 12.5 plus 9.2 plus 12.5, but that's a lot of typing. You might save a little time using the formula.
So it's 2 times base
Uh-huh.
plus side length.
Yes. So with that formula, what should I plug in?
2 times 12.5
Mhm.
plus 9.2.
Good. Perfect. And in your calculator, remember, you can type this all in one go. Just don't forget parentheses. You have to type the parentheses in. You will literally just type, I'll pull mine up. It will be 2 parentheses are above 8 and 9. Parenthesis 12.5 plus 9.2. Close the parenthesis. Press enter.
Close and enter 43.4.
43.4. That's
Times. That's it?
it. That's it. Because we already typed in that too.
Oh, I didn't put
We're
it.
done.
Yes, we did. Remember.
That's it. So
43.4.
perimeter is 43.4. And our units, because we're talking about length, it's just inches. You get the same thing? No.
It always means times.
43.4.
Yeah. That's it. Good.
Bad at all. You make things such stuff like that easier. Oh my goodness.
Yes. Okay. Anybody need more time before we do number 2? Okay, do this then.
Definitely makes it easier to understand, Diane.
Yeah.
Okay, number 2 is special.
Because it has nothing.
Yeah, it's got nothing.
Nothing.
Or does it? There's hidden information.
They're all,
Well, we all, yes.
Lacey,
No.
thank you. Repeat that louder.
they're all the same size.
So
How do you know these are all the
Because they all
same?
got the same tick marks.
It's
Well,
tick
also-
marks.
it's also a square, so
Okay.
It's a square.
Tick
Yes.
marks.
We want to pay attention to any labels. 13.7 inches, that side length is labeled with
If
a
them
tick
tick
mark.
marks,
Tick mark.
if you would have different numbered tick marks, that would identify that they were different sizes or
right.
different lengths.
Then we couldn't solve it.
Yep.
We wouldn't know. But since I know they all have one tick mark, they're all the same length.
Yep.
13.7
Mhm.
inches for all of them.
13.7. Oh, we can do it.
And you don't have to label them, but if you like to see it, go ahead and do it.
So that's gonna mean 1, 2, 3, 4.
I love how
4
you talk to
times.
Right.
yourself.
What?
I love how you talk to yourself. I'm waiting for you to answer yourself and Harvey. No.
Oh, that's right, baby. Okay. 13. Oh. Oh.
What you saying?
Are we getting ready to do that? Can we
Do
use
what?
4 times? 13.7. Can we do it in there?
We can.
Da, da, da,
What's
da.
that gonna give us?
Woohoo. I don't
Is
know
that
yet.
area or perimeter? If I
That
take it times
is-
4?
Area. A perimeter is around the perimeter. We're doing perimeter.
Yes. Okay, so let's go ahead and think about perimeter, Diane. Just figured out there's 4 sides that are all the
4.
same.
Parentheses.
What if we just take 4 times that 13.7?
13.7 parentheses. Wait a minute. 4 times 13.7. Yes.
And what did you
Enter
get? Same thing?
54.8.
Good, y'all got the same answer. So perimeter is 54.8 inches.
Yes.
Good job.
Awesome. Pretty cool.
Now how about area?
13.7 times 13.7.
Yeah.
Okay, 13.7 times.
9.
Hold on. Wait.
Because that's our base and our height, right?
Okay.
Now,
13.7.
and I really should have given you that these are 90-degree angles, but I'm sure you all assumed it. They are.
I thought they were 89.
They
Okay,
could
what
be.
is
You never know.
Okay, what are they around the corner?
Yeah, I put little squares, these boxes, to show that these are all 90-degree angles. So, But now, when we do that calculation, what numbers are we getting for area?
I got 187.69.
Did you time that?
Yes.
Okay, you time 13.7 times 13.7.
Mm-hmm. And
Yeah,
what are
I
my
see.
units?
Yeah, I see. 187.60.
Inches squared.
Inches squared. It's good. Now something else we could do here. This only works for squares. Squares are a special shape. Anytime you take a number times itself, you're squaring it, right? I could have done area equals 13.7 squared. If you type that in your calculator, you do get the same answer.
7. The same thing.
Get the same answer. Either one works. Were you able to get the square?
Okay, I like that.
So you typed in 13.7
13.7.
and then you push the X square button, which is right next to 7. So like 7, go to the
Oh,
left.
yeah, I need to add 2.
Yep.
And it said, okay, and then you push enter.
Mm-hmm.
187.69.
Yeah, there it is.
Okay, it's next to this. Thank you.
Yeah. Okay. Thank you. Anybody need number 2 still, or are we ready? Ready for 3?
Yeah.
Down. Number 3. What shape does this look like? It's a rectangle. We have opposite sides that are equal. These also have 4 90-degree angles that I didn't tell you, but I should have. Okay. They're 90 degrees, so I put little boxes in the corners. So, let's find the area. How do I do that?
53.2 times 23.1.
Perfect. 53.2 times 23.1. And that gives us big number.
And we gotta go like we did yesterday.
A very big number.
1,228.92.
Good.
23.
It will be 1,228.92. You don't have to write the comma in unless you want to. Some people put comma after the thousand place.
53.
You don't have to.
Now,
usually-
inches
Inches.
squared.
Good. How are your answers matching up, fella?
Well, I'm wondering, do we get inches squared is because we had to square the 53.2 and 23.1 or something?
So the reason that we get inches
That's what I
squared
thought too.
is because
Yeah.
we have 53.2 inches times another set of inches. So we we multiply the numbers, but we're also multiplying the units. Because what's happening here is I'm saying, what happens if I take, this is a line that's 53.2 inches, and I take it 23 different times. I'm eventually filling
okay.
up the shape. So
Yeah.
it's not a length, it's how many of these squares can I fit inside that rectangle?
Okay,
That's the
gotcha.
same thing I was thinking earlier when I
Yeah.
asked this. I was like, wait, because there's 2 of each.
Right.
Yeah.
Yeah, we don't actually square any numbers here, we just write square. Okay. Perimeter. What are we thinking?
That we got 2 times 53.2 plus 23.1.
Yes.
right?
Yes, that's right.
152.6.
Let's see, I bet you're right. You type it in all together. Oops. 70.2 plus 22.1. 152.6, that was it. Perfect. Perfect.
What was it? 152.6?
Yeah. That's awesome. And then, what would our units be?
Oh, inches.
Inches.
Yes. Very good. All right.
Once you know the formulas, it goes pretty good, don't it?
Yeah. And you guys, the rest of geometry is pretty much formulas.
That's it?
That's it. So if you
Yes.
like this, you're gonna love it.
Yeah, as
It
long
only
as
gets
you,
easier.
yeah, that's, if you got the formulas down, then it's pretty.
Yeah. Once you got the
Straightforward,
formulas,
huh?
That's right. It is. It's pretty straightforward. Okay. So leave that for a second, and then we're gonna move on to number 4 next. Now for number 4, you're missing some information. I want to make
the
sure.
height.
Yeah, we're missing the height. Is everyone ready for number 4 before we start talking? Okay. So number 4, we have a special type of shape here.
It's a triangle.
It's a triangle. More specifically, what kind of
A
triangle?
90-degree, but it's a, triangle's 360
It is.
degrees?
Not
Or 180?
180,
Yeah,
yes.
180.
So it's not twos.
It's
Is it not a bigger one?
right.
Oh, right.
triangle.
Okay.
It's not
Right,
right
yeah.
angle.
Yeah.
For the 90.
Now,
Oh,
in
okay.
terms of the degrees inside the triangle, I marked all 3 of them for a reason. There was a special triangle that we named by these angles. Does anyone remember from Unit 2?
30, 60, 90.
Yeah. Yes. It's a 30, 60, 90 triangle, guys.
Yep,
Mm.
yep,
You're
yep.
not going to like me for this one because we're
Bang, bang,
thinking
bang.
back. I'm going to turn my paper sideways because we normally see them this way.
Uh-huh.
And we actually normally see them even flipped around.
Yeah.
But we need to find this missing side
Yes.
first. So, anybody remember what we would label these as with our X values?
I can tell you here in a second.
Okay, yeah, look back in your notes. You may have it from Unit
Mine are
2.
soaked in the garage. I gotta retake them. But
So would 8.66 be 2x?
Almost. It's flipped around. It's backwards.
isn't that
so
the one?
X square root of 3?
That's
Yeah.
the square root thing.
This is our X radical 3.
Radical.
Radical 3.
Radical. Yeah.
What is our 10-inch side labeled at?
That's the 2x.
2x. And what's our shortest side?
X.
X. Okay. I need, let me flip this back around.
Uh-huh.
Flipping it back around. So, I need X. Which one of these is going to be easier to work with to find X?
You're 2x because that's double what x is.
That's right. That's right. If 10 is equal to 2x.
So what you do is 10 divided by 2.
So we have that equation already written out.
Yes.
10 equals 2x. We just divide by 2.
Yep.
And x equals
5.
5.
Alright, we found our x.
We found our x. Good.
Man,
It comes back sometimes.
it does.
Now, for this unit, something like this would be a bonus question. So don't freak out if you may have kind of forgotten that a little bit. But it's good to know that you guys can recall that and remember how to do it in the future. That's good.
I knew that was 5. I said it. I said this side is a 5.
That's right. So we have 5 inches. we have a base of 8.66.
Hey,
Yep.
question.
Mhm.
Okay, now the other ones, that one it wasn't the 60, 30, 90. It was the other one where it was the radical 2 instead,
Yes,
right? What was
yes.
that one called?
45.
Yeah, 45.
Yeah,
Okay.
yeah.
Yeah, but I knew it had the radical 2 in it.
Yep, you're right. So I haven't given you the formulas for these, but are we able to figure out either area or perimeter with this information?
On perimeter, you add all the sides.
Yeah, perimeter we can find right now because we have all three of our sides. So
Yes.
what would we do with those three sides?
Add them together.
Just add them together. So for perimeter, let's do 5 plus 10 plus 8.66.
23.66.
Awesome. That does give us 23.66. And our units would be
Inches.
inches. Good. We just added the sides. Now I'm going to give you a demonstration about where the area formula comes from in a triangle. I have this sticky note here. If I wanted to find the area of this sticky note, it's a quadrilateral, it's a parallelogram. We can use base times height, correct?
Yeah.
We can do that. I'm going to write on my sticky note, area of the sticky note is base times height for the whole thing. If I want to turn my sticky note shape, my quadrilateral, into a triangle, I'm going to fold it in half. Keyword in half. Would it make sense to say that the area of this triangle should be exactly half the area of the whole square?
Yes.
Yes, because it's just folded in half. So the area of a triangle comes from half of that formula for quadrilaterals. All we do is take base times height, divide it by 2. Or take it times 1/2. So I'm going to write that here. Area equals base times height, and we'll take a neat note on this in our notebook today. But we divide by 2. Base times height divided by 2. So all that being said, how would I find the area of this triangle?
8.66 times 5 divided by 2.
Yes, 8.66 is our base. Times our height is 5, we found. And then we just divide it by 2.
It's 5.
See, I'll type that in. 8.66 times 5 divided by 2. You should be able to do it all at once. Yep, 21.65. Good.
That ain't gonna hurt.
That's it?
That's it.
In inches squared.
Inches squared, you're right. Good. So bad, huh?
No.
No.
Pretty good.
Very good.
Hey.
You guys are also pretty smart, so that helps.
Huh?
They said you guys are pretty smart, so that helps.
Thanks to a certain teacher here.
Wow. I do what I can. So that's our do now, guys. Good review. Good review.
Yes.
Um,
That was awesome.
yeah. So I'm gonna pause this recording and I'm gonna pass out some papers to you guys that we're about to look at.
Are we making more notes in our book? Notebook?
Yes, we will be taking some notes as well. So go ahead and get your notebooks out, and I'm gonna come around with some papers for you. Okay, so I'm gonna put that do now to the side. And I just gave each of you 2 different handouts. One of them looks like this, polygon names. And the other one looks like this, bless you. It's a packet that says area/perimeter regular polygons. I'm gonna go ahead and write on this worksheet. This is our day 18 worksheet. So if you'd like to kind of keep things labeled, I would write that as well if I were you.
Yep.
And once you've got that labeled and kind of ready, we're going to open up our notebooks to a new page with, and we're going to title our page Geometry Unit 3. This page, and give it kind of a subtitle of regular polygons. Of course, these are our day 18 notes. I'm gonna write that at the top as well. Oh. So we need to know what a regular polygon is. If we look at this handout that says polygon names, we have a bunch of pictures of different regular polygons. First of all, a polygon, you can kind of break up that word. Poly means many or more than one, really more than 2, because you can't have a shape with 2 sides. And then gon, I probably need to look up if there's a meaning to that, but it's basically saying we have shapes with more than 2 sides. For a polygon to be a regular polygon, here's our definition. We're going to say closed. So regular polygons are closed shapes that have all sides the same length and all angles are the same measure. Closed shapes with all sides same length. All angles the same measure. So these are regular polygons. Give everybody a minute to write that definition if it's something you're writing. Now, polygons can refer to any shape with the same sizes, and the same angle measures. It can have a lot of different numbers of sides. You know, like on this handout here, we have a triangle, a quadrilateral, a pentagon, a hexagon, a heptagon, octagon. It goes on and on and on. That would make a lot of formulas if we were going to have one formula for every single shape. So we have found in mathematics a way to simplify an area and perimeter formula that will work for every regular polygon. So the first thing I'm going to do is give you the formulas, and then we're going to talk about it. So let me pull out my paper, make sure I give them correctly.
Sorry, Miss Taylor, I'm trying.
You are all good. I get it.
Trying.
This is the time of day where lunch is sitting in your belly.
Yeah.
Kind of
Yeah.
dim in here. It's a little warm. Start wanting to take a nap.
I'm always falling asleep.
It's your
Yeah.
voice
Came in here,
talking.
But once I came in here, I was wide awake going, well,
It's so
No.
slow.
what happened today?
Okay, let me give you some formulas. So first we'll do perimeter. Perimeter.
Stop laughing.
Perimeter for regular polygons.
Is that blue or purple?
Blue. It's like, it's a navy blue. It's dark. It kind of looks
couldn't
purple.
really tell.
Yeah, it's blue. You can tell maybe more on that. It's just a dark blue. So for perimeter, we are going to use the formula N times S. Now, N is going to refer to the number,
The sides.
yes, number of sides. Can you guess what S will be?
Side light.
Side length. Yep. So N is number of sides, S is side length. Area we are going to use different formula. Capital P times lowercase a divided by 2. Now, what that means, let's do this. I'm going to use some highlighters. Make the perimeter highlighted in blue. If you guys need highlighters,
Yeah.
there are lots of them on that wooden shelf at the front of the room. Feel free to keep some at your tables and your little pencil holders. So here, I'll pause for a minute and let you guys stock up. Now, so I've highlighted perimeter in blue because I also want to highlight the P in the area formula. It's perimeter. P is for perimeter. We have to find perimeter first because we need perimeter for our area formula.
You gonna give us an example to write down here?
Yes, I will.
Oh. Oh.
Okay. So P, writing it as perimeter. And A is a word that you may have never heard of before. I had never heard this word until I started teaching this class. I don't think I was even taught it when I was in high school. But A stands for a possum. A possum.
A possum.
That is so funny. So I have
get jokes.
A possum.
from
Who may put them out, Miss Teddy?
if any of you know Seth Ackerley, whenever he took my class, he made me this note for this lesson.
Oh, cash money.
It's a possum. So it's a possum, but if you had a list, a possum.
I mean, that's the line in the paper where that line is the, like, in this one?
Yes,
That's
it
cool.
is.
Did you
So
know
that's how you spell it.
Oh, wow.
I know, isn't that good? APOTAEM. A possum.
that is cool. Like that, yeah. You put it up. That's something. You ought to keep it.
Oh, I do keep it. I keep it. It's
That's
from a
cool.
long time ago.
Yeah, I was gonna say I ain't heard of him.
Right? Oh, it's a possum. He stays on my board. And then divided by 2 is just the number 2.
Yeah.
So these, I would do something in your notes so that you don't lose the formulas. They're important. Maybe make a tab in your notebook if you like to do that. So maybe write regular polygon formulas. And then I'm gonna stick it on the side here so that even when my notebook's closed, I can just flip right to it. Oh,
Okay.
make you a little tab.
That's funny. I like that.
Yeah, sticky notes are so useful. I use them so often. Okay. Now we're going to find examples of this, and something like this is kind of hard to draw. These regular polygons take a long time to draw accurately unless you're just tracing them on your paper. So maybe put a note in your notebook that says examples on day 18 worksheet, which we have labeled. And then we're going to do some examples.
Hello. How you doing?
Something like that. I know. I did. Okay, and then I'm just gonna rewrite those formulas on this paper as well. P equals N times S. And A equals P times little a divided by 2. You're ready for me to move this and go to the worksheet. Just give me a quick little thumbs up so I know. All right, Liz, is ready? And ready? Lewis is ready. Okay. All right, guys, I'm gonna scoot that up. Okay. And we're gonna look at number 1. Because these are all regular polygons, we already know without any tick marks or anything, all the sides are the same length. So what we're gonna do is label what our numbers represent. So for perimeter, we need the number of sides and we need the side length. So we're gonna start with N. How many sides?
3.
Number? Yeah, 3. 3. So if we want, we can even write 3 sides. So we don't forget where that n came from. Now we need S for side length,
38.1.
38.1. And that should be enough to find perimeter.
Okay.
So I'm just going to plug those numbers in to our formula. P equal N,
3
which is 3,
times
times S,
38.1.
which is 38.1. Good. All you do is multiply, and we'll see what we get.
3 times 31 is 114.3.
Good. 114.3. So we've got perimeter. Let's go ahead and write that below here. 114.3. And this paper actually does not give us units. So we're just going to assume inches. We'll put inches. So now we're going to hold on to that P for perimeter, 114.3, because we will need it to find an area. So I'm going to switch colors. I'll switch over to red.
Yeah.
So area
Equals
equals,
our perimeter, the 114.3.
our perimeter is 114.3. Now apothum,
Yeah, that word.
yeah, that is always going to be the length from the center of the shape going at a 90-degree angle to one of the sides.
So it'd be 11 then,
Be
times 11.
Yep. So I'm going to write A right here. That's my apothum.
Okay.
So times 11. And the rest of the formula is just divide by 2. And you can type this in your calculator all at once.
Okay, divided by
Once. See what you find for area.
Equal to 8.
which one you put first? Oh Lord.
You do 114.3 times 11, and you can even type divided by 2 all in one line.
So calculate.
628.65.
Yes. If you do that, you have to get the fractions first.
Right.
Then you divide by 7.
Yes. Now, luckily, because there's no addition at the top, we can do it all at once. Since multiplication and division are grouped together in order of operations, it will work. But if there wasn't any adding or subtracting, it wouldn't be right.
Man.
So 628.65, are you guys getting the same thing?
Yes.
Good. So if these were inches, what would our units be?
Inches squared.
Inches squared.
There's not like a unit or something. They're just assumed inches.
Yeah, we're just assuming inches.
Okay, what did I put down?
In sometimes if they don't give you units, like in another math class you may take, I don't know, they would have you write 114.3 units, and then you would just say 628.65 units squared.
Regular high school,
Yes.
they would never assume a unit. They would
Right.
just say units.
Right.
Because there was like
And that's probably a better way to do it, but we're so used to inches. Okay, now for type, all we're doing is naming that it's a triangle that has 3 sides. And we can use this little handout as a little cheat guide. So we would say that it is a triangle. That's our type.
Not my time.
Now, even though this is a triangle, don't use the triangle formula that I gave you in the do now. And that's because we don't have a height given to us. We don't have the units for that. Not enough information.
Okay.
So we're using the regular polygon formula since we know it's a regular polygon.
You gave us a vertically challenged triangle.
Yeah. Okay. How about number 2?
Okay.
Start the same way we did here, where we label our units, or not our units, our different variables. We have N, S,
It's a 3-side too, so in 3 sides.
3 or 3 sides.
Our S would be 45.
Good.
And then we can start from there. P equals 3 times 45. Three times 45. 135.
135. So for perimeter, we'll write 135. If you don't want to assume inches, you could write, I'll put units this time. Units. I'll find the area next. How do I do that?
With the units.
135 times 13.
Good. 135 times 13 are Polygons.
13 times.
And then last part is
Wait, by sure too.
divide that by 2. We get
77.5.
yes, 877.5. And this time we'll write for our units. We'll use units. Units squared.
Oh, okay.
Yeah, area is always square.
Yes, I did. Here it is always.
And what type of polygon is this?
A triangle.
That's another triangle. Good.
Can we
When it's triangle, that's because it's not enough
Whatever the bell
information.
rings. We got 4 minutes.
Okay.
4 minutes.
Are we just naming that
Yep, we're just naming
triangle, and it is?
Yep.
Is that because we don't have enough information, or we just naming it? Because
That
that's-
is because this is the most specific name we can give it. It is a 3-sided shape, so
And
it's a triangle.
Oh,
Yep.
okay, so that's good.
That's it.
That's that.
Now, for ones like number 3, where it's not 3-sided, we would need to count the sides and then decide what it would be called.
Actually,
So let's look at number 3. We may have time to finish it before the bell rings.
And the triangle is just triangle.
Yeah.
Yeah. 3 sides. Everything else is number of what it is.
what we going up in
Yeah.
Oh,
Except the.
Yeah.
Which one? But other than
Octagon?
that, an octagon.
octagon, yes.
Else is
It is
number
an
of
octagon.
sides is in Spanish.
And look at
Really?
that.
I didn't know that. Interesting.
we have
Yeah.
N and 8 sides.
The pentagon
Dikes.
Okay.
and the octagon are the only ones that do not go in Spanish.
Similar though, because 8 is ocho. Ocho sounds kind of like octo.
Sides.
Oh,
See, they go up in
6.2.
Spanish.
yeah, that's interesting. Okay, so for number 3, to find our number of sides, I know it might sound silly, but I always do this, and I know it will help you. I would mark them as you count. It's easy to count a side twice.
Okay.
I would go 1, 2, 3, 4, 5, 6, 7, 8. So my N is 8.
Ah,
There we go.
good idea.
And what would our side length be?
Interesting.
0.6.
Yeah.
There's 8 sides. And then
So we got P equals
right. You're right.
8 times 6.6.
Yep, 8 times 6.6.
P equals 8. Times 6.6. Like that. I. 52.
52.8.
Good. So perimeter is 52.8 units.
Units or units or inches or just?
Yeah, because
Either one.
Okay.
it
Either
can't
one.
be, because I'm just last, all in my head.
No, you can write inches, you can write
Well, I just
units,
kept writing
either
inches
one.
and you were writing.
On a graded thing, I will give you what the units are so that you're not guessing. Okay, so for area,
Okay.
Times 52.8 times 8.
good,
Yes.
8 is our bottom.
Divided by 2.
Divide by 2.
Two 11.2.
To 11.2.
Perfect. 211.2. Yeah, 211.
Units squared.
Units squared. And we name the type of shape based off of the number of sides. So what type is this?
This is an
An
octagon.
octagon.
I just do the name first because
Yeah.
that's the easiest way to do it. If
That's
you do that, you can just like, oh, there's the number.
Ah, great timing, guys. Okay, that is break time. It is 2 o'clock. So take 15 minutes. You will come back at 2:15 and do some more practice.
Okay.
Great job, guys.
Thank you.
Yeah. We are back from our break, and we just ran through 3 different examples of these regular polygon problems. And it sounds like you guys have a really good handle on plugging numbers into formulas, and that is good and wonderful and amazing. However, something that I think is the most helpful, maybe not necessarily in the solving problems portion, but in the understanding why we're using these formulas, is figuring out where did these formulas come from. So I want to explain where they came from. And I'm going to do that. I'm going to go back to my notes here. And I'm also going to grab, here's my handout. Is this one yours?
Yeah.
There, I use it. Nope. Okay. So what I'm going to do is I am going to see if I can trace picture. Yeah, I'm going to put a sticky note over the pentagon. And I'm going to trace it onto my sticky note the best I can. It's really difficult to see, but you can kind of see it
Oh, I can see it.
just a little bit. And I'm going to give a rough pentagon shape here. So we have here my pentagon. I'm going to put it back on my note page. And the things that I want to mark on this is a rough idea of an approximate center point. So I'm just going to put a point where it looks like it's right about in the middle. And then we're also going to draw a dotted line from that center point straight up and down to one of the sides, making about a 90-degree angle. We're drawing that approximate. So we'll put A. Then we are also going to label, let's put tick marks on each side length. And I'm gonna write S on any of those. So all of these are my S. Maybe I'll also put one down here so it's near the apothem. So what we have here is a sort of complex shape. When we're finding the area of, for example, a square, it's easy to see where the area formula comes from. We have our base and our height. If I take the base times the height, I'm saying my base, that length, times however much the height is, that fills in the area. For a shape like this pentagon, there's no clear way to just multiply two numbers. So we can also kind of think about our triangle formula, not a regular triangle, just like a 90-degree right triangle like this. We have a base and a height. So here I'm writing A equals base times height for the square. For the triangle, we do base times height again, but we also divide by 2 because it's half of a square. So that gives us our area. But again, when we're looking at something like a pentagon or any other polygon with more sides, there's no clear way to just stack these values up and multiply to make a nice triangle or a square. So what we're doing is we're breaking the shape down into smaller portions. And here's how I'm going to do that. I'm going to take the corners or each of these angles inside the shape, and I'm going to draw a line from the corner to the center, like that. And I'm going to do that with all 5 angles inside. Just like this. And now, once you've done that, you can see we've broken our pentagon up into 5 triangles. We have a triangle formula, right? We have the base times height divided by 2. Now, in this case, my base of this one triangle, maybe I'll do this. Focus that. If I'm focusing in on one triangle, the base of this one triangle would be S, my side length. So I could also label that as my base. What would my height be?
The apothem.
The apothem. So if I wanted to find the area of just this part, I would be taking S, which is our base, times our height, or A, apothem, and then I would divide by 2 because it's a triangle, right?
Yeah.
This just gives me the area of one triangle. If I wanted the area of the whole shape, I would need this area times 5, right? Because there's 5 of these triangles. So I would take that whole thing times 5. Now this would be a really kind of complicated way to do it.
So times 5 triangles, right?
Yes, because there's 5 triangles.
Gotcha.
Now, if we think about how we use N, S, A,
Yeah.
P, this shape, this pentagon, our N, or our number of sides, would be what?
5 triangles. 5.
5. Okay, so we have N. Our side length
Yeah.
would be S. Whatever it is, I'll put S. And so what we would do first is we would find our perimeter, which is number of sides times the side length. So n times s. There's our n, the 5,
Yeah.
and it's getting multiplied by the s in our area formula. That's why we have perimeter in the area formula. Then it's taken times the a, the apothem, because here's our area formula. P times a divided by 2, right? All we're doing is n times s. 5 is n times s times a divided by 2. We just simplified it to p times a divided by 2, or perimeter times apothem divided by 2. So the reason that we use this as the area formula is because some mathematician years ago decided that I can do this for any regular polygon. I can break it up into a bunch of triangles. And if I find the area of one triangle, why don't I just multiply it by the perimeter? Because that is going to, that's going to be used anyway for the area, rather than having to take it all separately. So that's just a little visual of where that comes
Oh,
from.
that's big. That's not 6.
Yeah. So again, this isn't something that you have to have written down necessarily, but if it helps you see where it comes from, then great. If not, I appreciate you entertaining me anyway. So that's fine. So, so move this back to that worksheet here. Let's do one more together, number 4. And after that, I'm gonna have you guys try to do a few of these on your own. See how well this is done. Before that, can I move this note page? Yes. Good. All right, moving it. Okay. Number 4. Last one we'll do together. Before I give you time to try some on your own. So for number 4, what's a good way to start this? What should I
How many sides there are?
figure out? Say it
How
again.
many sides there are?
How many sides there are? Okay.
7.
So
Do you
yeah.
take
1, 2, 3, 4, 5, 6, 7. Good. So n is 7.
So then we do 7 times 14.1.
Good. Our side length is 14.1. So we multiply the 2 to get our perimeter.
Yes. Okay.
Thank you. 7.
Perfect. Perfect. Okay, what are you doing? And when you multiply 7 times 14.1, you should get 98.7. That is our perimeter. Right, you had tens. You could also put inches. You can put yards. I don't know.
Office
Anything.
units.
Anything. You can put miles. Whatever you want. Now that we have perimeter, how do I find my area?
Oh, so 98.7 times 14.7.
Good. Times 14.7. That's our hypotenuse. Divided by 2. Good.
Yeah. Yeah.
Tell me when you get an answer for area.
1,144.
Let's see, 98.7.
It's not even on.
Did you?
I also did it differently a minute ago and got a different number when I typed it back into the calculator, so I could have also just typed something wrong.
I think you're on the right track. Did you divide by 2?
No, not yet.
Okay, divide by 2 and that'll get you your
Oh,
answer.
They just say these batteries is on.
Okay.
I didn't divide it by 2, I just punched the.
I was
This one's
checking.
that.
I'll put some new batteries in that after class. So 725.445. Is everybody getting that?
Yeah.
Good. And remember, area is always squared. It's a heptagon. Good. Heptagon. 7 sides. You do not have to memorize these different polygon names, but don't lose that handout.
It's a heptagon.
Heptagon.
Yeah.
Because of the 7 sides. All right. Okay, so we've done 4 of these together now. This worksheet packet has tons of problems. I'm going to set a timer for, I'll give you 15 minutes. I want you guys to work on this worksheet and just see how far you can get. Do some good practice, and then we will see how we're doing when that timer goes off. So I'm going to pause our recording and give you guys some more time. All right, so you guys have had 15 minutes. I'm going to flip to the second page. And what I'm going to do is go through and give you the answers for them. If at any point any of your answers don't match the ones that I give you, circle that question, wait till the end, and then we can go over them once we get through all problems. So, for number 5, you should get, I'm going to use inches for my units. Perimeter was 104 inches. Area, 743.6 inches squared. And it's 1, 2, 3, 4, 5 a pentagon. What'd you say, Ella?
I just use units.
Perfect. Units work too.
too.
Right. Number 6. Our perimeter is 72.8 units or inches, or whatever you chose. Your area, 400.4 units squared. And this is octagon. It has 8 sides. Okay. Number 7. Our perimeter should be 274.4 units or inches or whatever. Your area, 5,584.04. Yep. Units squared. And this is another heptagon, 7 sides.
Oh, hepta.
Hepta. Yes. Hepta.
Yes, it is.
7. All right. Number 8. Perimeter is 70 inches.
Yeah.
Area, 336 inches or units squared. And this is another pentagon. 5 sides. Number 9. Perimeter is 76.2 units, inches. centimeters squared. Area 419.1 units squared. And this is hexagon. Good. Good. All right, number 10. Perimeter is 87 units. Area is 522 units squared. And the type is another pentagon, 5 sides. Okay, that is the second page. And we're about to go to the third page, see if you people are still writing some answers. I'll wait just a minute. All right, page 3, number 11. Perimeter, 62.3 units. Area, 286.58 units squared. And this is a heptagon. 7 sides. Okay. Number 12, our perimeter is 95.4 units. Our area is 438.84 units squared. And the type is triangle. Number 13, our perimeter is 104.4 units. Our area is 835.2 units squared. And the type, this one has 9 sides.
Nonagon.
Nonagon, yes. Nonagon. Nice. Okay, 14, our perimeter is 85.6 units. The area is 552.12 units squared. And we have 8 sides. Gives us an octagon. Last page. Last page. Number 15. Perimeter is 86.4 units. Area is 561.6 units squared. 8 sides. Another
Octagon.
Yeah, octagon. Number 16, perimeter is 36.8 units. Area, 103.04 units squared. 8 sides, another octagon. Number 17, perimeter is 83.1 units. Area is 332.4 units squared. 3 sides. Is a triangle. Okay, number 18. Perimeter is 50 units. Area is 172.5 units squared. And there are 5 sides. So we have a pentagon. Yes. Number 19, my perimeter is 30 units. My area is 43.5 units squared. And it's a triangle. Finally, last but not least, our perimeter, 69 units. Our area is 345 units squared. We've got 6 sides. So
Hexagon.
it's a hexagon. Good. Okay. So that is the whole packet. Now, as we went through and did those, if there were any that you finished that didn't match the answer key, maybe we want to look over. Were there any that we wanted to look at?
I don't even look at them. I got 2 wrong because I didn't put enough sides on there when I did that.
That's what I
Boom.
got. I got one wrong because I did it
Boom.
with 7. So
Yeah, I put 7 instead of
Boom.
8 on 2 of them.
Right.
Yep.
Yeah. Okay. Good deal.
This been a good day.
Yeah, they did great. So it is 3:02. You guys, y'all rocked it today.
No. You killed it.
No, you. So what I'm going to do right now is we've got about 28 minutes left, technically, of class. I am going to take about 5 minutes here to create an exit ticket for you guys and get copies made. If you need to take a little break, stretch your legs while I'm doing that, feel free. And I will have those copies ready in just a moment. But once I have that exit ticket, that will be all. Yeah, so I'm gonna pause this and get that ready. So I'm gonna flash this exit ticket on the screen. I will make copies of it, but this way you can at least start working on it and then
Got
copy
it.
your answers onto
Yeah, I
your.
get it. I'm tripping.
Yeah. So don't feel like you gotta try to draw this. You can work it out though, and I'm gonna bring some copies back in here. This is the problem. You'll find the area and perimeter of this shape. Name the type of shape, and that's it. So that's all today.
Thank you.
Uh-huh.